Hey everybody, this is Mr. Beckstrom, and today I want to take a look at using right angle trigonometry to find the lengths of sides and angles of a right triangle. Given that we have some information of that triangle already, usually we're given two pieces of information. In this case, we're given two of the sides. We could be given one of the sides and one of the angles. The only time that we can't really find the other information is if we're just given two angles. Why is because if we just are given the angles of a triangle, that angle can be large or as small as we want it, right? Because think of if you have like a triangle with like a 60, 60, 60, like an equilateral triangle, right? You can have a huge triangle with all equal angles. You could have a really small triangle with all equal angles. So that doesn't, you can't really determine the lengths of the sides with just knowing the angles of a triangle. So we usually at least have to know one of the side lengths. All right. So in these kind of problems here, they're going to give us just the letters here. So when I write out my triangle, the only thing that I need to do, they don't even need to give me this triangle here. All I need to do is write down a right triangle, right? So first thing I need to do, and I can write it down however I want. I can put the right angle on the lower left, I can put it on the lower right, I can put it on the upper right, doesn't really matter. I just write a right triangle, and here's what I want to do. The uppercase C, I always put that with the right angle, and the lowercase c is always going to be my hypotenuse. That's always going to be opposite of my right angle. So we usually place the C, the uppercase C, straight across from the lowercase c. And that's going to be pretty common when we're using the A, the B, and the C. And then with the lowercase a and uppercase a, it doesn't matter. You can use that for either of the two legs, just make it consistent. So if you use the lowercase a for this leg over here, make sure you use the uppercase a for the angle opposite that leg. So here I chose the bottom leg here for the lowercase a, so this angle opposite, that means not touching this lowercase leg, or the lowercase a here, that will be my angle, my uppercase a up here, and the same thing with my b. So this is my other leg, and so my uppercase b corresponds to this side over here, so the opposite angle will correspond to this leg here. And that's how you set up your triangle. So once again, you just write down your triangle, your right triangle. You set up your C's first to correspond with the right angle and the hypotenuse. The uppercase letters will always go for your angles, and the lowercase letters will always go for the corresponding opposite sides of those angles. All right, so once we have that done, let's go ahead and put the numbers where they go just to make it a little bit easier. I'm going to freehand this, so it's not going to look extremely nice, but hopefully we can at least read this. All right, so that's 19 there, and this over here is 14. All right, so in this case, we want to know C, we want to know A, and we want to know B. They're not asking big C because we already know that. That's a right angle, which means that's 90 degrees. All right, so let's go ahead and find little c first, and we can do that just using the Pythagorean theorem. And that Pythagorean theorem tells us that a squared plus b squared is equal to c squared. So I'm going to write that right here. A squared plus b squared is equal to c squared. And then I'm just going to replace a and b. So a squared is going to be 14 squared. So let's go ahead, I'm going to write it out the first time here just so you can go back. Plus 19 squared, or I think I put them in the reverse thing, but it doesn't really matter there. So here's a squared, there's b squared, but addition is commutative, so it doesn't matter which way I put it in. It's equal to c squared. And then I'm going to go ahead and put this so 14 squared plus 19 squared, enter. So this is going to be 557 squared is equal to c squared. Oops, not 557 squared, it's 557, excuse me, is equal to c squared. So c is equal to the square root of 557. I do not believe that is a perfect square. Uh-oh. Oh, I was just freezing there, but it looks like I'm okay. So that's pretty much it. And then what we can do at this point is we can approximate that going to one decimal place. So let's go ahead and see what that is. So square root of 557. It looks like that's going to be about 23.6. So that's going to be about 23.6. And one kind of thing I can check, now this doesn't mean that I'm right, but it also means that I'm not wrong, is that this C, the hypotenuse, should always be more than your A and your B. So if it happens to be less than your A or your B, then you know you did something wrong. So your hypotenuse should always be longer than both of your legs, which it is. So if it was smaller than it, then I know I did something wrong. All right. Now, in order to get your A and your B, we're going to have to use the trigonometry. We're going to have to use the sine, cosine, tangent, or technically we could use secant, cosecant, or cotangent, but those are just inverses. So let's not go ahead and get there. But using sine, cosine, and tangent, we're going to kind of use the principles of SOHCAHTOA. So let me go ahead and write that down. So SOHCAHTOA. All right. And let's talk a little bit about what this means here for a refresher for some of you. Maybe some of you haven't actually seen this. If you haven't, make sure you're reading through the section and trying to understand this more. SOHCAHTOA is talking about the sine, which is opposite over hypotenuse, the cosine, which is adjacent over hypotenuse, and the tangent, which is opposite over adjacent. And what that says is that we can look at the we can look at the ratio of any two sides of a right triangle using these trig functions. Okay, we can look at the ratio of any two sides of a triangle. And technically, if you look at a triangle, there's 3 sides. So there's 6 total combinations of one side over another side. And there's 6 total trig functions. And that's why we have 6 trig functions. Because I could have C over B. I could have B over C. I could have C over A. I could have A over C. I could have B over A, and I could have A over B. That's 6 total combinations of one side over another side. And each one of those combinations refers to one of those 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. So that's kind of where we get the trigonometric functions from. So the 3 basic ones are sine, which is opposite over hypotenuse, the cosine, which is adjacent over hypotenuse, and the tangent, which is opposite over adjacent. The cosecant, which is related to sine, is just the reverse, is hypotenuse over opposite. The secant, which is related to cosine, which is just the reverse of the cosine, which is hypotenuse over adjacent. And the cotangent, which is just kind of like the reverse of tangent, which is adjacent over opposite. So you can kind of use those with SOHCAHTOA as well. You just have to kind of go the other direction there. Now these work from either of the acute angles. That's an angle that's less than 90 degrees of a right triangle. So it doesn't work with the right angle here. It works with either the A angle or the B angle. Now, you have to use either A or B with that in order to make this work. So, and remember, these will always be acute. Why? Because the angles of a triangle have to add up to 180. So if you subtract this 90 out, that means these have to add up to 90, which means that technically they both have to be under 90. All right. So in order to solve, to get one of these angles, let's pick one of those. Let's say we want to do B first. It doesn't matter which one we want to do. Let's just pick one. So I want to start with B. So, and I want to use one of these trig functions, sine, cosine, or tangent, in order to solve for B. So, and I know what A is, I know what B is, and now I know what C is. C is 23.6, 23.6. Now here's just a little bit of information for you. They gave me A and B, and I know that A and B are exact numbers, but C here came out to an irrational number, right? So I actually had to round that. So this is not an exact number. If I look back at my calculator, it came out to a number that's going to really go on forever. So I actually had to approximate this. And what that means is, just a little tip for you who are working these problems, is that if I can avoid using this number in my calculator from now on to find the measure of these angles, I'm going to avoid using that. And that's what I'm going to do here, because this one is just an approximation, but these two are accurate. So that's what I'm going to do. So when I pick a trig function to use with this angle B, I want to use these two sides. Now, this side over here is the opposite side of B, and this side over here is the adjacent side of B, because this side over here is always the hypotenuse. So which of these three trig functions uses the opposite and the adjacent? Remember, the opposite will be the side that's not touching the angle that we're talking about, and the adjacent side will be the side that is touching it, that is not the hypotenuse. So that would be the tangent function. That would be this one right here. So I can set up a function that says that the tangent of B is equal to the opposite side, right? The opposite over the adjacent side, all right? And that's what I got it from this right here, from the SOHCAHTOA, the opposite over the adjacent. So the tangent of B is equal to, my opposite side of B is 14 over my adjacent is 19. Now I want to solve for B, so I want to get it by itself. In order to get it by itself, I have to apply the inverse tangent to both sides. I have to apply the inverse tangent. That's another trig function. So the tangent of an angle gives us a value. The inverse tangent of a value gives us an angle. It's an inverse function. So if I apply the inverse tangent to both sides, the inverse tangent of the tangent just gives me the B is equal to the inverse tangent of this side would be the inverse tangent of, and inverse tangent is written like this, of 14 over 19, like this. And this is where we use our calculator. So B is equal to, and I go to my calculator, Now, I'm going to end up, I want to give this in degrees because unless otherwise stated, I'll always want to give an angle in degrees. Let me clear this and you go to your mode. It's already in degrees. If it wasn't, I would want to change it to degrees, but I'll very often change between radians and degrees depending on how I want to give my answer, but we're already there. So second quick, go back here. And in order to do inverse tangent, here's the tangent key. The inverse tangent is right above it, so I'm going to do second tangent. Oh, I hit that wrong. Second tangent. Inverse tangent of 14 divided by 19 is, and I'm going to go to one decimal place. So that's going to be approximately, so I should probably do approximately, what was that again? 36.4. So 36.4 degrees. And then the last one I have to find is A. And I could do the same thing with A. I could set up a ratio just like I did using opposite and adjacent as well. Or I could just make it a lot easier and say I know that all the angles have to add up to 180. So I can just do 180 minus the 90-degree angle for C minus the one that I just found, 36.4. And that's going to give me my last one of 53.6. So A is going to give me 53.6. 53.6. And there you go. So that's how we're going to do a lot of these types of problems that you're going to do in that section. I hope this helps. Please let me know if you have any questions, and have a great week. Thanks.